All right. Hello, everyone. Welcome. Today I'm going to be going through Qual Lab stuff. So we're going to talk about, final report, what that looks like in the hopes that that'll clarify how to do everything. So if you want to grab Qual Lab to follow along, you can. If you just want something to write a couple notes down on, that's also fine. You don't have this packet at this point. This is something you'll get when we get closer to the end. But this is going to be the only thing you turn in for Qual Lab. And today I'm going to show you what it looks like to fill it out. I'm going to show you some old students' work that filled them out and talk about, good and bad with that. And kind of give you a breakdown of how to do this. I am going to record this, so I figured out I should probably put myself in spotlight. Whoops, sorry, fifth hour. So anyway, I'll have a recording posted for this so that if you want to watch it again, I'll try and download it and put it on YouTube so it sticks out for the whole Qual Lab. Anyway, hello YouTube. Feel free to leave a comment, subscribe. All right. Anywho, all right, let's talk about this stuff. So this is going to be the final thing you do. I don't have like a typical schedule right now. So normally we do the Qual Lab all in 4 weeks. Like we start on a Monday, we end on a Friday, and it's 19 days. There's a Memorial Day off in there. And we have a really like kind of strict schedule, and I know exactly when things are. This year, obviously, I don't have that because it's very chaotic. The schedules are different. The classes are longer, but they're less frequent. And there's a whole bunch of issues with quarantines and stuff like that. So I eventually will give you some guidelines of when the end of this will be. But I don't know what they are, and we're going to make sure that you have plenty of time. So I don't want to kind of say, oh, it's going to be in 3 weeks or 4 weeks. You got to be done and stress you out. Like we'll find a way to make sure that everyone has plenty of time to do everything
Just
till the very end. So I'll
all right.
answer all the questions at the end. If you have one, write it down. But it'll be much easier if I just go through the whole thing. So yeah. Anyway, if I had to guess right now, I would guess that we'll do this for another 4 weeks after spring break or up to 6 weeks. So somewhere in that range will be when we see the end of it. And the end of it will look a little different depending on what your attendance has been. So if you've been there nearly all the time and you've only missed like 1 or 2 days or something like that, usually what happens is you'll finish all of your lab work and you'll be able to do your report over the last couple days in class. If, on the other hand, like kids, usually we do this during May, and a lot of kids take off their AP exam day and the day before. So some students will miss like 5, 6 classes of those 19. Those students usually have to work up until the end in the lab, and then they have to do the report at home. So today I'm going to show you what the report looks like. I'm going to show you some examples. Let's take a gander at this. Okay. So front cover of this looks the same as what your packet looks like right now. So that's why I didn't pass them out. You guys would mix them up. And then this is what when we say you turn in a report, this is what you turn in. You don't do a report for all 10 of your unknowns. We're going to pick 3 of them at near the end, and you're going to do those. And you won't know until we get close. We kind of do like a random thing for it. Excuse me. But what I mean by that is that like you might write up your number 2, your number 8, and your number 9, but you won't know until we get to the very end. Or you might do your numbers 1, 5, and 6. I don't know. So we'll go through a couple different examples. The very last page of this, the conclusion page, this is a big deal. This is where you write down what you think your 10 chemicals are. So you'll get to see some of the former students, what they did for that and what they got right and wrong. But this is going to give us the kind of structure of how we do this. So this top box, some of you have already gotten to this point. So let's talk about what you would have there. So let's say we pick a number and you're going to do unknown number 6. Okay. So hypothetically, for your unknown number 6, it's an SSI. So when you have your solubility profile, that limits from 73 down to a smaller number of possibilities. So we would start filling those in, and we would fill them in order. And I'm not going to put every single one here, but I'm going to put a few so that you get the idea. All right, so these are some of the SSIs in the first group, the halide group. Okay, there would be a couple more. I don't remember all of them off the top of my head. The second group would be the hydroxides, the carbonates and bicarbonates, And again, I think there's probably just K2CO3, but anyway, whatever. There's another group of those. Then there's 2 phosphates. And then there's the potassium ferrocyanide. Okay, so we would have a couple more here. I don't know exactly how many. There are slightly more of these. I think there's 9 and 7. Then there's 2 of these, 1 of those. So we have this combination of things that this could be based just on its solubility. Let's say that our color, that there's no color to it, so we call that colorless. Let's say that it is basic. And let's say that there's no odor. Okay, so we do all of our pre-tests. This is what we come up with. So colorless. So when we deal with colors, if it's blue, that doesn't really mean a ton. It could be one of the blue ones, which would be the copper ones, or it could be a colorless one that I've added food coloring to. There is no food coloring I can add to a colorful one to make it into colorless. So any of the chemicals of these possibilities that are colorful are going to get eliminated here. So basically, colors eliminates other colors, but that's not what you write. You have to write out the actual ones that it eliminates. So of these, which of these are colorful? Well, there's 1. And the 1 is the potassium ferrocyanide. So this one is yellow. And so the theory here is that if I gave you this and it's yellow, there's no way for me to turn that yellow solution into something that's colorless. So we eliminate that one. The acid-base test. So for acid-base, when you do this in the class, you're just writing down what color the universal indicator turns. But if it turns blue or violet, that indicates that it's basic. And if it turns red or maybe red or orange, that's going to be acidic. So if it's basic or acidic, that can cause some eliminations, but not many, because there's a lot of stuff on here that you would not expect to be acidic or basic, and we don't really know about at this point. So we want to be cautious with this. So if it's basic, basic is going to eliminate acids, and there are 4 of those. There's HCl, HNO3, HC2H3O2, and H3PO4. So here, because we're basic, we can eliminate any of these 4 that are in the solubility grouping. And of that, there's 1. Oh, and I forgot to put it. Here, I'll put it at the front here. HCl. So HCl would get eliminated from that. That's in the SSI solubility. We drop that out. Okay. If this had been acidic, then I would have been able to eliminate acidic eliminates hydroxides. So if I had NaOH, KOH, any of those NH4OH, those 3 would have been eliminated if it had been acidic. Okay. Other than that, there are other things in here that are acidic and basic and neutral. We don't eliminate those. If this is neutral or it's close to neutral, we don't eliminate any of those. The goal here is that we're trying to eliminate really stark differences, and we're not trying to really use these to do much elimination. Odor is not going to eliminate anything no matter what. So even if you have an odor, there's always the possibility that that test tube is touching another test tube or something else is causing the contamination. We want to do an actual test because this is just really unreliable. Okay. But after that, I would rewrite all of these chemicals over again in here, except this one would now be gone and this one would now be gone. And if eliminating the chloride changes the numbers of these enough that these are now out of order, I would reorder them, but it wouldn't. But sometimes that'll happen. Okay. All right. So that's where we are in class right now. Many of you have done solubility testing. Many of you have looked at whether things are colorful, acidic, or basic. We've smelled them. And now we're here and we're like, okay, now what do we do? So this is where the actual Qual Lab begins. So for this, what we're going to be doing is we're going to be doing anion tests first. And what you do for anion tests is you come back to your remaining possibilities here that we're going to, I haven't written up here, but we're going to pretend they're down here. And you go, okay, which grouping do I have first? Well, the first grouping I'm having is the halide group, which is the chlorides, bromides, and iodides. Now, because this says anion, I should have charges here. So I don't write Cl, I write Cl minus, I write Br minus, I minus. And this is how you do the Qual Lab. So you go through and you say, all right, I could have one of these 3 things. I want to figure out if I do or I don't. So what you do is you write down the standards that you're going to test with. And the standards are any of the 73 chemicals that we know. So for instance, NaCl could be a standard I use here. That's a standard chloride. I could use KBr, or I could use Ki. I'm going to use all three here. So you're going to pick one or one of each, in this case, of the 73 chemicals. And then you're going to write down a brief procedure of what you do for the test. And then you can write down a brief result. Okay, so 1 drop of the standard in a well plate plus 1 drop of silver nitrate. Then I do 1 minute of UV light. Okay. And then the result is for the chloride, I get this color and this texture of precipitate. For the bromide, I get a different color, different texture. Potassium iodide is creamy and it's this color. And then I do the same thing for my unknown. So I have my unknown. I write a brief procedure. It's going to look pretty much the same as this. I'm going to rewrite it though. And then I write my result. Now, each of these results here has a different color and texture to it. If this one matches one of those, that's what I have. So if one of these is like purple and it looks like sand, and this is purple and it looks like sand, well then hello, that's what I have. So let's say I have a match and it's the bromide. Okay. Well, then what I'm going to do is I'm going to come up here to all of my remaining possibilities and go, how many of these are bromides? And I'm going to write every single one down here. Okay. If it's a chloride, I'm going to write down every single chloride left. That's what I have. And at the bottom, I'm going to fill in that I identified my anion as chloride or bromide or whatever it is. But let's say I don't get a match. Sad day. What do I do next? Well, now I come back and I say, okay, so now it's not one of these. These are all out. I've eliminated that possibility. So now I go to my next group, the hydroxide bicarbonate carbonate group. So now I'm going to do that test. I'm going to do the hydroxide bicarbonate carbonate test. And I'm going to pick out, NaOH. I'm going to pick out NaHCO3 and Na2CO3. And I'm going to write down a brief procedure of what tests I do. I'm going to get my results and write down my brief results. I'm going to do the same thing with my unknown. I'm going to write down the brief procedure, and I'm going to write down my results. If they match, that's what I have. If this one and this one match, then I have a hydroxide. If this one and this one match, I have a bicarbonate. If this and this match, then I have a carbonate. Okay. And this one's actually multiple steps with multiple results. So you're going to do, test 1, here's the results. Test 2, here's the results. And if one of them matches all of them, that's what you have. Okay. Let's say they don't match. Now, the only possibilities I have left are this one and this one. Remember, I eliminated my ferrocyanide, so I just have these two as my last remaining things. So now I'm going to do a phosphate test. I'm going to grab Na3PO4. I'm going to run my test on it. I'm going to write down my procedure here. I'm going to write down the result here. I'm going to take my unknown. I'm going to write down the procedure, and I'm going to write down the result. If they match, great. Then I'm looking at Na3PO4 or K3PO4. Those are my possibilities. If they don't match, then I'm in trouble because now I'm out of possibilities. So if you get to that point, and that probably will happen at some point, then you got to go back and go, okay, either this is wrong, something in here is wrong, or something in here is wrong. And you're going to have to figure that out. You're going to have to go, well, you know what? I thought these didn't match, but these two were actually pretty close. Let me go double check it. Or, you know what? These all didn't match, but I was testing NaOH, and maybe I need to test the NH4OH because that one is the one that turns into water eventually. So I'm going to go double check that with NH4OH. Or maybe you're like, you know what? I wasn't sure if this was a SII or SSI. So I'm going to go back and check the solubility. Or maybe you don't know. And then you probably want to start back at the beginning at the solubility. So you go through and then do it again. And hopefully you get to a point where you're like, oh, okay, I see what I did wrong. And I figured out what I have. Now, at that point, later, like in a couple of weeks, you're going to start being able to do cation testing and figure out what the other part is too. All right, so let's take a look at what that looks like when a student turns in their Qual Lab. So this one here is pretty good. This student here has an SSI profile for their unknown number 5. This is from several years ago. So they wrote down all of the halides, all of the carbonates and bicarbonates and hydroxides, the 2 phosphates, and the potassium ferrocyanide. Their solution was colorless, so they should have eliminated the potassium ferrocyanide, but they didn't, so there was a point. It was neutral, which doesn't eliminate anything, so none. And then odor, there was none, so we don't eliminate any. So then they recopied every single thing. And then at this point, I could take off a second point here because they have the wrong thing there, or I could go, I've already taken off the point. So it depends a little bit on how much stuff you have on your page, but that's always an option. Okay, so then they did the halide test, chloride, bromide, iodide. They took this control, this is their standard, calcium chloride, calcium bromide, and potassium iodide. And they added silver nitrate in the UV light. This one turned this one looked like this one looked like this. And when they did the same thing to their unknown, they ended up where it looked like this, and there was a match. So they knew they had a chloride, and they wrote the remaining chlorides possible. Okay, that ended up being correct, and they identified that they had a chloride. From there, they went on and did the cation testing, which is often flame testing. And they put this standard into the flame and it turned pink, this standard into the flame and the fire turned red, and this one caused the fire to turn orange. Their unknown caused the fire to turn red, therefore it was lithium, and they ended up with lithium chloride. Cation is a lithium plus, and the chemical formula is LiCl. So out of 30 points for that section, they lost 0 here and 1 on the other page. So that student's doing great. They had a 29 out of 30 on the first page of their report. And then they go on and they have other ones, right? So they had another SSI, and they also had a SIS. So like here's an SIS. They have all the chemicals. They're in order. They're written with correct formulas. They did the color. They eliminated every color that was not blue. Acidic would eliminate bases, but there are no hydroxides up here, so they didn't eliminate any. No odor, so it eliminates none. So then they recopy all of them except for the ones they've eliminated, these 7 or 8. They did a nitrate test. Here's the standard. Here's what they did. Here's the result. Here's what they did for the unknown. Here's the result. It was a match. The remaining possibilities are these nitrates. Okay. Now, that's rare. I mean, it's nice and all, but you know, this one was a very high ACE score. Okay. But hopefully you can see that you can do that. This one here we're looking at something that's a little bit, you know, a little bit not as good. So we have an SIS. Okay, so here we've got all the chemicals. Everything's grouped in the right order, and there are no spelling errors up here. But they put clear instead of colorless, so that's minus a point. And colorless should have eliminated all of the colorful ones. So they lost some points here. And then this is a big mistake. So they had odor of vinegar and they eliminated all nitrates and sulfates. So they lost a whole bunch of points there. And then down here, the zinc acetate, they forgot the 2. So they were sloppy there. They lost a point there. When they did their testing, they didn't write down what standard they used. And they also didn't write what they did for the unknown. So they lost some points there. And overall, they lost a bunch of points. Okay. And that one, they got correct. And then on the cation test, they had some errors here where they didn't put the standards, and then they didn't put, they did put the thing for that, but they should have put the procedure for the unknown, okay? And then here, this one, they made a mistake. So they thought they had magnesium, but they actually had zinc, and their instructions on what they were supposed to do for this test is missing a couple steps. And so they lost a whole bunch of points for that. So this student ended up down almost 20 points out of the 30. So they had about a 30% on that report because there were several critical errors. Now in other ones, they did a little better. And so they ended up with a final out of the 90 points for the report. They ended up with a 60 out of 90. Okay. And then overall, that student ended up with a B- on the report. So with the curve and with the last part. So that's what that can look like. And then I have one more, and this one before the curve was failing, and then with the or without the curve was failing, and with the curve was Still not doing so well. But they passed slightly. Anyway, so like for example, here's one page of theirs. This one was silver nitrate, if I'm not mistaken. So IIS, only two possibilities. They have the formula wrong for the silver nitrate. They had colorless, which is correct, but they didn't write down that it eliminates none, so they lost a point. They didn't run the acid base test, so they lost a point for that, and they lost a point for not writing what it eliminates. And then remaining possibilities, they didn't write them again, so they lost a couple points there, and they spelled silver nitrate wrong. Now, silver nitrate, lead nitrate, this one's super quick. You only have one option, so you got to confirm that it's a nitrate, but other than that, you really don't have to write that much. So the student only lost 5 points. If this had been a longer one, like an SIS, they might have lost a lot because now they're missing out on 20 chemicals here. I'm not going to take out 20 points, but like I'm going to take off more than two. Same thing up here and here. These were each missing one tiny thing. So even though it was a big error, they lucked out on this page. So this student ended up with a score that was a little bit lower. And then let's see here. So as far as the final page, this is where they ended up. So number one was correct. Number two, this one's wrong. And not only is it wrong, this is not even a possibility. So strontium chloride was their chemical. They put strontium bicarbonate, and there is no strontium bicarbonate of the 73 chemicals. So they should have known that that was incorrect. So if that had been one of their report pages, I would have been really critical on that page, especially if they weren't following the instructions well, or if they were leaving stuff out like in their other parts. This one was the opposite. That's a very reasonable mistake. These two are really hard to tell apart, the bicarbonate and the carbonate. This one, these are in totally different solubilities. Sodium hydroxide is a SSI. This is an SIS. And not only that, but sodium hydroxide like has a very distinctive silver nitrate precipitate. So like this is a big deal. This is wrong. If this had been one of the report ones, I would have been very critical on that. This one is just, they didn't write the formula correctly. This one, again, is not a possibility. And then this one, again, was in the wrong solubility. So this student definitely didn't do great work, but still ended up, passing, I guess. Let's see. What else? Huh. I wanted to show you like a more typical one. So this other student had a, where did I put my third paper? Oh, right here. So this student had a 17 out of 20. So I want to show you what that looks like. So number 1, 2, 3, 4, all correct. Number 5, the magnesium is supposed to be zinc. 6, sodium was ammonium. Really easy switch to make. That one's hard to tell apart. And then 10, sodium for potassium. So they had 3 ions incorrect out of the 20. So even though they had potassium carbonate, like they had the carbonate correct, so they get the 5 points for that, but they lose the 5 points here. Here, they get the 5 points for the acetate correct, but they lose the 5 points for the magnesium and zinc switch up. So when you're doing your check day in the last couple of weeks, if you turn this into me, then what I would do is I would go, okay, they've got this wrong, and this wrong. And then I would go, okay, so your score out of 20 is 17. And the only info you would get from me is that number. And so when you get to that point, you have to then go through and go, okay, 17 out of 20, am I good with that? Or do I want to go through and do I want to try and figure that out? And that depends a little bit. Like if you had one, like you're like, I can't tell if there's a bicarbonate or a carbonate, and you get a 17, you might go, okay, well, I'm pretty sure that's where my issue might be. So I'm going to start there. And now that I know that I have something wrong, maybe all of a sudden it clicks and you're like, okay, when I run this test, it's clearly now I was on the wrong side of that. I'm going to flip that. And now I'm probably up to an 18, but maybe I don't know the other two. I don't know where to look. They all feel like they're correct. So that's kind of a game time decision that you make at that point of like, all right, what do I feel like I know? Do I feel comfortable in that? If you get it back and you get a 12, then you're probably likely to go, all right, I need to like double check my solubilities. I need to go back and really like any of the ones that I'm uncertain about. I need to make sure that they're kind of matching up. That part of this is all kind of up to you. So starting today, I'm not really going to help you with that. If you come up with something, you're like, does this look like this? I don't really want to interject on that because I don't know. You're going to spend so much time on this. And for me to jump in 2 seconds and I might tell you the wrong thing, I want no part in that. So any of your like, is this thing a SIS or SSI? I don't really want to tell you the wrong thing. I'm going to leave you up to you to figure all that stuff out. however you need to kind of come up with that thing. And so you're going to be able to go through and do all the experimentation you need in order to get to that point. Okay, that's what I wanted to show you. My hope from that is that that gives you a sense of like how you're going to do moving forward from this point. So at this point right now, when you come back, if you know your solubilities of your unknowns, what you're now doing is going, hey, my numbers 2, 5, and 9 are all SSSs. I need to run a nitrate test and then either an acetate or a sulfate. And you know, like until you get to a point where you get it. If it's a nitrate, then boom, you stop right after there. You finish the anion for that one. You know what it is. If that doesn't work and you do the acetate test and that doesn't work, you go on to the sulfate and that's what it is. You stop there. So as soon as you have a confirmation, you stop with the testing and then you kind of move on to the next unknown. And so how you structure your time is up to you, but you want to be smart about, you know, you only have the test tube full of solution. So you want to structure it in a way where you're like, all right, I only need to do these 3 tests. So I'm going to do those 3 tests, figure out what it is, and still have plenty left in case something goes wrong later that I have enough to kind of do another double check for. Okay, that's a whole bunch of stuff. I'll now open up. So what questions do you guys have? You guys can either post them in the chat or you can let me know. You can send them to me privately. Any of those things are fine.